Unit number 3, factors and products. Some definitions. We say something is a multiple, like 12 is a multiple of 2 because it's 6 times 2. Yeah. So the multiples of 2 would be 2, 4, 6, 8, 10, 12, and so on. Any even number is a multiple of 2. A factor of a number is something that divides it nicely. So for example, 2 is a factor of 6 because you can divide 6 by 2 and get 3. We would say that 5 is not a factor of 9 because if you divide 9 by 5, you get a decimal, and it's not a nice number. Well, it's still a nice number. We don't want to be mean against decimal numbers, but not a whole number. So factors are basically checking your times table. A prime factor is a factor that is also a prime number. Did you know that 1 is not a prime number? Because technically to be a factor needs so that the only things that multiply to get that number are 1 and the other number. And then if you have 1 and 1, it's the same number. So they've decided that 1 is not a prime number. The first prime number is 2. 2 is the only even number. And a very famous problem that has yet to be proven is if you pick any random number, any random whole number. It's that hard? Pick a random number. 58. If you take 58 and double it, you'd get 116. And between 58 and 116, there should be at least one prime number. No mathematician has ever proven this, but all mathematicians believe this to be true. I think I call myself a math. 17 is a prime number. You could take any random number. So for example, if you take 2 and double it, you get 4. Is there a prime number between 2 and 4? Yes, 3. Right? 2 is the only even prime number. If you take 21 and double it, you get 21 and 42. There's 31 is in between them. There's at least one prime number. But what happens if you tried something like 8,732 and doubled it? What's the prime number that's in between there? It'd be hard to find. Okay. Well, now they have competitions to find, well, they used to have competitions to find prime numbers until a mathematician found a formula to find any big prime number they wanted. Okay? But for a while there, they had like the largest known prime number, and you could buy posters of it, which would be like really cool to have. Big prime number poster. Okay. Prime factorization, you did this in grade 9. Do you remember doing this? That 24 is actually 2 times 2 times 2 times 3. You can always break a number up into its prime factors, and that can be helpful for figuring out a number of things. Okay? For example, do you remember doing greatest common factor in grade 9? So if I had two numbers, let's say I had 18, okay? Let's say I had 18 and I keep doing 18 and 60. What is the greatest common factor? What divides both 18 and 60? 6. So sometimes if you know your times table really well, you can just see what's the number that divides both of them and what's the biggest one that divides both of them. But if you wrote out, because 18 is 6 times 3, which happens to be 2 times 3 times 3, And 60 is 6 times 10, and 6 is 2 times 3, and 10 is 2 times 5. And you circle something they have in common. Oh, they both have a 2. Anything else in common? Oh, they both have a 3. The greatest common factor is 2 times 3, 6. So we could use the prime factorization to find the greatest common factor. We could also use the prime factorization. Do you remember this in grade 9? The lowest common multiple. So what is the lowest common multiple of 8 and 60? I mean, one way that you could do it is you could just list them. The multiples of 60 are 60, 120, 180, 240, and so on and so forth. Okay? Good. 180, you're saying that's the one that's going to be in common. Because 120 doesn't work for 18. Okay, so we're saying that the lowest common multiple is 180. We can also use the prime factorization to find the 120 is you look at 2's. This one needs 1, 2, but this one needs 2, 2. So for your lowest common multiple, you are going to need 2 2's. What about 3's? This one has 1, 3. This one has 2 3's. So for your lowest common multiple, you're going to need 2 3's. Any other numbers? Yes, there's a 5. So you will need a 5 as well. If you multiply this out, 2 times 2 times 3 times 3 times 5, you get 120. Or 180, sorry. Which is what we sought. And we are now correct. So you can use prime factorization to find greatest common factor and lowest common multiple. Anybody see a good strategy to do this mental math? This is what I did. I did this. 2 times 3 times 3 first. Because that's not hard. 9 times 2, do you get 18? Why is that strategic to do first? Because then what's left to multiply by? By 10. And 18 times 10 is 180. A little bit easier than doing 2 times 2 is 4, times 3 is 12, times 3 is 36, 36 times 5. No, yeah, 180. Okay. Prime factorization. So one of the ways that you can figure out the prime factorization is something called a factor tree. You start off with 144. Can you break that up into any two numbers? Doesn't matter which ones. 12 and 12. Okay? You could also divide by 2 and get 2 and 72. So let's do them both separately, and you tell me which one you like better. And I just want you to see that it doesn't matter if you chose 12 and 12 or 2 and 72. Okay? So a factor tree says keep going until you get to a prime number. Can you see that 2 is a prime number? So on the one on the right, you now just have to break up 72. So some people like just dividing by 2 all the way. Oh, this is going to be 2 times 36. And other people like to break things up like this so that they can, what two numbers give me 12? 4 and 3? Perfect. 4 and 3. And can you see that you could do that for both of those? Okay? Then, the 3 is a prime factor, but the 4's I could break up to be 2 and 2. The 36, 2 and 18, the 18, 2 and 9, and finally the 9, 3 and 3. Some people like to take out a different color pen, and once they get a prime factor, they circle it. And here I got my 3's, and then here I got my 2's. Whichever method you use, we can now write the prime factorization of 144 from our factor tree. How many 2's are there? 4 of them. So we can write that as 2 to the 4 times by. How many 3's are there? 3 squared. So the factor tree is a method for us to write out 144 as 2 to the 4 times 3 squared. Now, what I really like about do we have to do prime factorization? I just want to show you something that's really powerful about prime factorization. And I want to see if you can figure out how I'm doing this. Okay? Tell me, looking at your prime factorization, the following. 144 is equal to 18 times what? $144 is equal to 18 times what? 18 times 8. Do you see how the answer is there? Okay? 144 is equal to 16 times what? There's 16. 16 times 9. And so having the prime factorization lets you develop your times table so much faster and so much quicker that you can see things you might not have seen before, right? And sometimes you can take numbers that you know that multiply and rearrange them to multiply to get new numbers, things that you might not have seen before. So for example, what's a good example? Yeah. You know that 6 times 9 is 54. Can you see that you could use this and go like, oh, 6 is 3 times 2. So, oops, that's 9. 6 is 3 times 2. If I just break up the 6 to be 3 times 2, can you now easily see that 54 is 3 times 18? That's going to be helpful for breaking up your numbers and seeing different things. The prime factorization is, I think, really cool for that. Try this one on your own. 2646. Without a calculator. Because it's even. You can divide this one by 2. How do you know you can divide it by 2? Because the last number is even, so may as well start with that. Is that a prime number? Are we done? No, you can divide that by 3. Three times what equals that? 3 times 200 will give you in the 600s. So it's probably more than something in the 200s. Ooh, I like this. 3 times. Is it going to be in the 200s, 300s, 400s, 500s, 600s? 400s. How do we know? Because 3 times 400 would be 1,200. 3 times 500 will be 1,500. So it's going to be 400 and something. Okay? So if 3 times 400 gives you 1,200, you need to get another 123. 4 again, because that'll give you 3 times 40 will give you 120. Oh. Is 441 a prime number? No, you can divide it by 3. Is it going to be 100s, 200s? 100s, because that'll give you 300. Now you still need another 140. What would I? 140s. 3 times what gives you close to 140? 3 times 4. And then there's 21 left. 147. Now this would be harder without a calculator, unless that divides by 3. I'm going to teach you how to tell if something can divide by 3 in a second. Oh, second's going to ring. So let's do this quick. 3 times? To get to 120 would be 60, 40s, right? And then 49, which is 7 times 7. So the prime factorization of, let's just circle with a different color. This is prime, 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 prime. 2 times 3 cubed times 7 squared. And here it is. How do I know that 147 divides by 3? If you add up the numbers, what's 1 plus 4 plus 7? 12. And if the number that you added up to divides by 3, the original number divides by 3. That works for 3 and for 9. I'll show you 11's trick next class if you remind me.